Hey everyone, Mike on Monday coming to you. Today I have a special guest with us. We're going to be talking about the Silurian Bedrock of eastern Wisconsin. So one of the things I wanted to point out is that Country Visions has a wide variety of specialists on staff. Some of you may not have known, I didn't start in agriculture in school. I actually started in reclamation, which means I've got a number of years of geology in my background. But with me today is Amy Haak, a geologist with Country Visions. And Amy runs our nutrient management plan team and is the lead on a lot of things and integral with how things are working with the state, etc. So Amy, welcome to Mike on Monday.
Great. It's really fun to be here today, Mike.
Awesome. Thanks for coming. So to the point, Silurian Bedrock, where is this?
Well, I brought a few prompts with me today to help with this discussion. This is the state of Wisconsin. We have 15 counties that are outlined here in yellow, and those are the 15 counties that have Silurian Bedrock. So Dodge and Fond du Lac County, Calumet County, up through our trade area. The pink on this map are the areas where the Silurian bedrock is the shallowest bedrock unit that we have. Okay. So this is, it doesn't extend through the whole county. It's mainly the eastern parts of some of these counties and then along the lake shore. Just to give you a little geology lesson today, you remember from school that Wisconsin was covered by these huge continental glaciers. And so what we have is that when the glaciers moved down and retreated, they are huge erosive forces. They took a lot of soil away, they took soft rock away. The Silurian bedrock is a very, very hard unit. So this was left at the surface or near the surface when the glaciers receded the last time. Although this rock is very hard, it is extremely fractured. There are two sets of fractures. There's horizontal fractures and there's vertical fractures. So when we get water moving into this rock, it can travel down, it can travel across, it can move like through stair steps.
Sure.
So it can go quite a long ways.
Okay.
And when we have contaminants in that groundwater, that means the groundwater can go a long ways.
Contaminants go
with the groundwater. Contaminants move with the groundwater.
Yep.
So when you have wells in the area, you can start contaminating a whole variety of wells that are down gradient from where our area of contamination was. We hear a lot about brown groundwater events, and that's what we're trying to avoid with this standard.
Okay. So how do I know this applies on my farm?
Well, if you look at the distribution of the shallow bedrock, this map shows the colored areas are where it's 0 to 20 feet. We've kind of identified these areas as being most vulnerable because the soil does not have a buffering capacity if we have very shallow soils. So any place where we have bedrock that's less than 20 feet is where we're very concerned with this. This is where the standard has been targeted. So this map would give us an overall idea of where we have it. Okay. Then you can look more specifically at your farm. If you have a nutrient management plan, we can look at the map that comes with your plan. Any place you have purple shading, it doesn't matter which direction it is. The purple shading means you have shallow Silurian bedrock. You have Silurian bedrock that is less than 20 feet and you fall under the standard.
Okay. So what if I think the map is wrong?
Well, that's a really good question because we know that these maps weren't made to determine shallow bedrock on a field by field basis. They weren't, we don't have the data density. So what we've been doing at the co-op is we've been going out and doing some verification, especially of the very, very shallow areas like the 0 to 2 feet, where with this new rule you cannot spread manure. So we have come up with an easy way to do it, a cheap way to do it. We went and bought a tile probe at Menards, about 25 bucks. And I had our shop guys grind some lines on it at 1 foot intervals, which you can't see, so I put tape on them just for kind of an idea.
Sure.
And so we take this probe out to areas where we think you could have shallow bedrock. Very, like I said, we're concentrating on 0 to 2 feet with this. So we're gonna simulate this using our bucket here, where I would take the probe and I just simply push it down into the soil, and where it stops, that's probably our bedrock, and we measure that.
So I'm measuring from the top of the bucket, which is the soil line, to my next mark on the probe, and I've got 9 inches to my next mark.
So this line represents 24 inches. We have 9 inches below that, so we have 15 inches of soil.
15 inches of soil.
So in this case, we cannot spread manure at this location. We go across the field, we continue on down the road, take a sample here, take a sample this direction, we make a map based on that. We can import that data into your nutrient management plan, and then each of these points is recorded with GPS coordinates. So the regulatory agency, whether it's the county or the DNR, can come out and they can actually check this, and hopefully they agree.
Sure. So if my farm has a lot of rocks on, how do I know I'm not just hitting a rock versus bedrock when this probing is being done?
Good question. After you use the probe a few times, you kind of get a hang of what it feels like, and I can tell you when you're pushing down and you hit that bedrock surface, you get a pretty good jar off of it in a lot of cases. There are some times when you hit something that you can't get around and you might feel it wiggle, and then you probably don't have bedrock. All I do in that case is I just offset a few inches and try to push it down again. If I have the same stopping depth, I probably am on bedrock.
Okay.
If it goes deeper, probably not.
Okay.
Probably just a rock.
So Amy, can you tell us a little more about this 24-inch depth? I heard you say, in our example here, that we only had 15 inches, and we're not spreading manure on that 15 inches, but it's more the 24. Tell us more about that depth.
So with this standard, anyone who has manure on their farm is not supposed to spread any manure in areas where there's less than 24 inches of soil over the bedrock.
Okay.
And that's simply because when we start introducing that manure with pathogens in it, they travel way too fast to that bedrock surface because we don't have that buffer of a nice thick soil layer.
Okay. So what changes do I need to make to comply with this new standard?
Okay, so in addition to the areas where you can't spread, those very shallow areas, we're gonna have increased setbacks along direct conduits to groundwater. So you're gonna have increased setbacks around your wells, tile inlets, and concentrated flow channels.
Okay.
Then when we actually start applying liquid manure, we've got some more new changes. The first one is that you have to do pre-tillage. And the idea of the pre-tillage is that you break up any wormholes or root traces that can act as conduits to help infiltrate the manure faster, deeper, to places where we don't want it. Then after you pre-till, you apply your manure. It does need to be either injected or incorporated within 24 hours. And they actually set maximum depths you can do your injection at.
Okay.
There are also some rate limitations, and those injection depths and rate limitations vary by how much soil you have over the bedrock.
Okay. I think I heard you say that there might be a difference between liquid and dry manure.
Yeah, because solid manure doesn't have as high a liquid component, we're less restricted with what we can do with that.
Okay.
From 2 to 5 feet, we are limited to less than 15 tons of manure in an application. And there are also tillage requirements associated with applications of manure. From 5 to 20 feet, we do not have the restrictions. So you can pretty much carry on as you have been.
So at this point, what do I need to do to comply?
The rule actually went into effect in July of 2018. CAFOs have had the requirement to not spread manure on areas of 0 to 2 feet already previously to this rule. So with the expanded maps that we have, we've been doing a better job of doing that, keeping manure off of those areas. As CAFOs add land to their permits or their permit renews, then they do have to follow all of these rules in the standard. The small farms have a longer time frame to get implemented. They have to be offered cost share before they can be required to take this on. But we have a lot of farmers who are very concerned about their reputations. They don't want to contaminate their neighbor's well. They don't want to contaminate their own well. So they're starting to do some of these things already. Especially trying to evaluate the most vulnerable areas of their farm. Really this is kind of a long-term planning process for a lot of people. So I just encourage you to start thinking about areas of your farm that are the most concerned to you. Talk to your agronomist and come up with a plan of action.
Awesome. So a lot of changes coming. We're aware of scenarios of shallower soils, less buffering capacity. We want to take action on those as soon as possible to reduce any impact that we have on the environment. Our goal here is to grow good crops, create a healthy scenario for everyone in that area that we're working. And this is one of the ways that we're gonna get closer to being more environmentally friendly as we move forward. Amy, I want to say thank you very much for joining us today on Mike on Monday. And if any of you folks have questions on this new standard on nutrient management planning or any of the overall agronomics, feel free to pick up the phone, call us here at Country Visions, talk to your agronomist, and we'll do our best to help you with all those questions and challenges that we have ahead of us. With that, Mike on Monday, we'll see you next week.